Hi, and welcome to Chapter 4, Part 2. This is Dr. Payne. In this video, we'll be discussing outer joins. In the previous video, we discussed inner joins. If you didn't watch that video or you need a refresher, I would encourage you to go back and watch that one. Again, this one we're going to discuss outer joins. We're going to discuss the keyword union, intersect, and minus. So let's go ahead and get started with the overall syntax of an outer join. Again, we start with our select and our from clause. We have our list of columns, we have our table or our list of tables, and then below that we have these keywords left, right, or full. We're going to be going over each one of those types of joins, the left, right, and the full. The outer is again in brackets, so you don't need that. It's not commonly used. I would recommend not put it in there. Then you have your join table on whatever condition. And then you can continue down and join as many tables as you want to. Remember, if you're joining 3 tables, you're going to have 2 join keywords. If you're joining 4 tables, you're going to have 3 join keywords. So you're going to have one less, just like you're going to have one less condition if you use the where statement. So let's go on right into our left join. Again, we have these subsets of data. So the left join means I'm going to take everything in this case from table 1, and then I'm going to take the data where it intersects with table 2. So I'm going to take just the common pieces that I want from table 2. So I'm going to take all my rows from the left table, and then I'm going to add the additional columns or the additional information from table 2. Let's see how this works in SQL. So the actual syntax for the left is you still have your select your from. You have your left, again, I wouldn't use outer, join table on whatever condition, and then left join table on whatever condition. So what this literally means is that the table to the left of this word, which would be table 1, means you're going to take the entire table, and then you're going to join the information from table 2. So you're going to take everything that is literally to the left of the word left. So let's go ahead and let's look at an example. So this example is trying to go and trying to identify the customers who have placed an order. You can have more customers. So you have a customer that's come in and created a profile, but maybe they haven't ordered yet. So maybe what you want to do is go and send them a special, send them, a coupon for so much off, send them free shipping. But you want to be able to go through and identify them. So you have your select statement, which we've seen from the last video, hasn't changed, from our customers table, and then we again have our alias C. We're going to do a left join on orders. So we're going to take everything from our customer table. We're going to join our order information. And in this case, our order information is our order ID. We're going to join them on the customer ID, and then we're going to sort them by the customer last name. So let's go ahead and into SQL and see what we get. So we have our statement in here with our left join. Again, it's going to take everything from customers. So let's go into our customers table just real quick. So in our customers table, we have 25 records. We're going to pull all 25 of those records. So if I go into order management, my order management SQL, and I'm going to pull all of my customer records, I'm going to match them on their order IDs. So let's go ahead and let's run this. So after I run it, I have all of my records. It says it fetched 47 records. So it's got all of my customers in here, and it has all my order IDs filled out. So what it's saying that every customer in here has an actual order ID. So I've gone in and I've added a new record. Again, don't worry about that. We'll figure out how to add records a little bit later on. And I come back into order management and I run this, and I should look for Payne, and it should not have an order ID next to it. And there we go, Wendy Payne, no order ID. So what this does is this displays all of our customers and their associated orders. So we see here Jonathan has 2. It's taking everything from my customer table, it's joining it on my orders, and if it has an order ID, it will display it in my second column. If not, it will display null. So that was my left join. So let's go ahead and try it for yourself. go into accounts payable schema and use a left join to create a report to display only the vendors who have an invoice listed by the vendor name alphabetically. So I want all vendors and I want their associated invoices. You guys can probably think of a different way to go through and do this, but I want to make sure that you use a left join for it. So go ahead and pause it, try it. All right, welcome back. So your select statement should look similar to this. We're going to select the vendor names from invoices. We're going to join on vendors. In an inner join, it doesn't matter what table comes first. In an outer join, it absolutely matters. In this case, it's a left join. So it's going to take everything from invoices and it's going to match up my vendors to them. It's only going to bring back my vendors if they have an invoice. It's going to match them by vendor ID and order it by my vendor name. Well, this is okay, but I will end up with data that's a duplicate because I have vendors that have multiple invoices. So if I go and I add distinct to it, it will only bring back that vendor name once. So in order to, really you're going through and you're trying to identify your vendors. Maybe you are going to go and you're going to send out another coupon to your vendors that will say that if you pay in 30 days that you want a discount or something like that from your particular vendors. This will go through and give you that list of invoices. It doesn't tell you right now whether they're active or inactive, but this distinct will go through and clean that up a little bit. All right. So moving on to the next one. The next one is a right join, and it's the exact opposite of the right. It will take everything that's in table 2, and it will take the information that is from table 1 where it matches the information from table 2. The exact opposite of the left join. So if we come in and we look at the syntax, we can see that the only difference between the syntax here is a word left and right. Our select clause, our from clause are the same. In this case, we have a right join and a right join. We're still joining them on a condition. So let's go ahead and let's look at an example. This example will take the customers and will join it on the orders, which means that it will identify everything to the right of the word right, in this case, orders. Everything from the orders table will come through. So every order ID will come through. And it will match on the customers who have only placed an order. So let's go ahead and take a look at this. So I'm back in SQL Developer. Again, it's going to take everything from my orders table and it's going to match my customers. So one way to go through and check it is to go into your orders table and we can quickly see how many records that we have in here. In this case, we have 47 records. All right, so coming back into my order management workspace, I'm going to run this query and I should get my 47 orders. We can see there, again, I have multiple names because I have multiple orders, but I have one record for every single order and I'm matching the information from my customers table. I'm grabbing everything from my orders table because it's literally to the right of the word right. And my customers is to the left of that, so it's only going to take the pieces of information when it has a matching record. All right, so now I want you to try it for yourself. I want you to take the exact same SQL statement and I want you to change the word left to right and I want you to run it and I want you to identify the differences in the data that is returned or the report that is returned. Then I want you to go and actually come back and create a SQL statement that will do the exact same thing, which will create a report to display only the vendors who have an invoice listed by a unique vendor name alphabetically. Remember, the unique, we're going to use distinct for that. So go ahead and pause this and come back in when you're ready. All right, so we're in SQL Developer. And I just wanted to show you the solution to this real quick. So we have our left join, which we all know we come up with 34 records. So if I change this from left to right and rerun it, you'll notice I come up with 50 records because it's taking all of my vendors. It's to the right of this. It's not taking all of my invoices. So let me move this back to left. And so what I have to do here is I'm changing this from a left join to a right join. And when I do that, I want to make sure I take all my invoices, and I want to join on my invoices, which are literally to the right of the word right. And my vendors come first because I only want the vendors where they have an invoice. And when I run this, I should come up with 34 records. So let's go ahead and move on to the next one. All right, so our next join is a full join, which means I want everything that matches from both tables. I don't necessarily want just the information from my table 1 or just my information from my table 2. It's going to be very seldom that you're going to do a full outer join, but I wanted to go ahead and I wanted to show it to you. So the only difference here is instead of a left or a right, it's full. My recommendation is never to do a full join on more than 2 tables at a time. So in this case, it's going to be table 1 and table 2. All right, so let's go ahead and look at an example. So in this case, I'm going to take the last name and the first name and the order ID from my customers table, and I'm going to do a full outer join on all my orders where my customer numbers match, and I'm going to order it by the last name. So let me go into SQL Developer and let's take a look. I have my query in here, and it's going to grab everything from my customers and from my orders. Remember, I added that one new customer record to it. So I should really end up with the number of records in my orders plus 1. So if I go into my orders table, remember I have 47 order records. So when I run this, I should end up with 48 because I'm doing everything from customers and everything from orders. So let's go ahead and run this. And I come down and I have 48 records because I added myself and I don't have an order ID associated with it. And that should be my only null that I have. If I go, I can filter these out and I can look at the null and there's only one there. Let me just make sure there's only one record. If I do that, it comes back with just my record. So that's just another way that you can go through and you can double check your query. And I'm going to come back in and I'm going to remove is null, and all of my data is now there. All right, so let's try it for yourself. I want you to go and I want you to use the accounts payable schema. I want you to create a report that will display all vendors and all invoices listed alphabetically by vendor name. This is just a way where you can go through, maybe you're auditing your tables, you're auditing your data, you're making sure your data is in sync. So go ahead and give that a shot and come back. All right, so you should have come up with a SQL statement similar to this. In this case, it doesn't matter if invoice or vendors are in the from clause or in the full join statement, because you're going to join both tables. So I'm going to join the tables where my vendor IDs are equal. All right. Next one is our Cartesian product. This is a cross join, and it says all possible rows are merged or connected to all possible rows of another table. You never want to do this, but I want to show you what it is so that when you come across it, you can be aware of it. So here's an example of our Cartesian product, and I'm going to go ahead and go into So we're in SQL Developer. Here's my Cartesian product. I'm taking everything from my customers and my orders table. You'll notice I have no join, no using, no where statement. So if I run this, it's going to come up with a tremendous amount of records. If I keep scrolling down, I can keep on scrolling. You can see that it's going to continue to increase. Maybe I've actually hit the bottom of 1,222. So here we have Miss Story that is assigned every order ID. And then we come up here a little bit more and we have Bailey that's assigned every order ID. The data doesn't make sense, but you may run into this. You may come up with a Cartesian product, and I just wanted to show you what the results would be. All right, our next one is joining multiple tables. We've really spent our time just joining two tables. You can join as many tables as you want to. If your joins are getting too intense, and you probably want to create a view, or you want to look at how your data is actually set up, your tables are actually set up. So remember I said earlier, if you're joining three tables, you're going to need two joins or two comparison statements in your where clause. So here we're joining customers, orders, and order detail. What we're doing is we're trying to find out what they're actually ordering. So we're going to join our customers and our orders based on customer ID, and then we're going to join our order tables and our order detail table based on order ID. This SQL statement is the same as this SQL statement. In this case, we're just using join instead of where. So we can, again, join as many tables as we want to. Both of these are inner joins because there's no left, right, or full. The last one that I wanted to talk about is joining four tables. And these are joining four tables using the using statement. So we are going to join customers with orders using customer ID, order detail using order ID, items using item ID. So it's similar to what we saw in the previous one, but this is just join using. And these are four tables. If you have four tables, if you're joining four tables, you're going to have one minus that join statements. So go ahead and try it for yourself. I want you to join the vendor contacts. I want you to pull out their last name. I want the invoices, the account number, and I want all of this sorted alphabetically. So go ahead and take a moment to do that. And then you should have come up with something similar to this. Vendor name, last name, invoice ID, account number from vendor contacts using vendors, invoice, and vendor line item, all ordered by vendor name. All right, so at the last few portions of chapter 4, we talk about the union statement. The union statement will take everything from this select statement and everything from this select statement. These select statements are full statements in and of themselves. So my recommendation when doing a union is to write each statement separately and see your results, and then put in the word union, put in the keyword union in between them, and you will see the results that you get. But any compound select statements or any complex ones, always start small and then add to it. For a union, the number of columns must be the same in both select statements. The column data types must be compatible, and the column names in the report are taken from the very first one. So an example of this is active as source, which means that we are just going to go and we're going to write the word active and everything in that column. And then we're going to display it as source. Then we're going to have our invoice number, invoice date, invoice total. We're going to take all of this from our active invoices where our invoice date is greater than or equal to June 1st. We also want to go and we want to identify our paid with this. So let's take this into SQL Develop. So for the union, we have two different queries. We have our select query that is going to retrieve information from the active invoices, and I'm in my example schema. These two tables, again, don't mean a lot in the other two schemas, and so the example schema is where we can find a bunch of tables that we can go and we can do some examples with. So I'm going to pull up from my active invoices where my invoice date is greater than or equal to June 1st, 2014. I'm going to run just this one, and it comes up with 12. And I'm going to union it with this other one, this other select statement, where it's going to take information from the paid invoices, and the paid invoices has to have the same invoice date. So I'm just going to run that one as well. So I had 12 with the first one, and I have 10 with the second one. So when I union both of these, I should end up with 22. So let me grab the whole statement and run that. And if I come down, I have 22. And you can see here in my source column, it puts either active or paid. These are literal strings that you can put in on any column really. And this is just paid, but you want to make sure you have an alias. If you don't have an alias, it's not going to work and it's not going to be very readable to your user. Again, you don't have to have the as. You can just have the source name. from that. So you don't have to have the as. I removed it, and if I rerun it, it will come up with the same information. So again, this is union, where it's taking the information from here and the information from, it's taking the results, excuse me, of this query and the results of this query and combining them together into one report. So the next one we come to is union all. The difference between union and union all is that a union will eliminate duplicate rows. So if you want these duplicate rows included, you would use the union all. In this case, in this example, it's going to produce the exact same results because we took everything from our first result set and everything from our second result set and came up with 22 records as our overall result. So in this case, the example is not the best. So our next one is intersect. And what intersect does is it takes the results from the first query and the results of the second query and finds the information in common. So if I have from my first query, I have a James Smith, and I have a James Smith from my second query, it will return that in the result set. So here's an example. I want all my customer IDs from my customer table and all my customer IDs from my orders table. What this will do is it will take every customer then that has placed an order. I've seen other ways to go ahead and do this. Intersect is just one more tool you have in your toolkit. And the last one is minus. What minus does is it takes the result set from your first query and it removes the result set from your second query. So you may have a query here where you didn't want any invoices that were earlier than June of 2014 from your overall query. Again, different ways to do it. Here's an example. I have my customer IDs from my customer table, and I'm going to remove the customer IDs in my order table. So if you have customers that haven't placed an order, that's going to be the result of the query, of the overall query. So let's go ahead and take a look at this. So this should return, remember I added myself as a customer. It should return that customer ID. And that customer ID, let's go ahead and look real quick in the customer table. And in the customer table in my data, I'm customer ID 26. So the results of this should be 26. This will return all of my customers, all my customer IDs, so it goes down through 26. And this query will return every customer ID except for 26. I should have placed them in order. But we can see here real quick that there's no 26 in there. So when I run those together, it's going to give me my customer ID 26. Because customer ID 26 exists in the first result set, it doesn't exist in the second one. So now I want you to do your practice exercises. You can complete everything from practice part 2 of chapter 4, and you can complete all the chapter exercises that are at the end of the chapter. If you have questions on joins, please contact me. You can email me, you can call me, you can come see me during my office hours. Thank you so much and have a great day.